Hello, I'm Datong from Peking University. Today I'm going to introduce our work predicting mouse click position using non-short-term memory model trained by joint loss function. Mouse as an efficient pointing device is essential to various computer systems. Knowing mouse movement and points in advance is beneficial. For example, when users interact with network applications, network latency can lead to long waiting time. If the system knows where the cursor movement may end, it can take action in advance and the user experience can be improved. The prediction results can also be combined with pointing facilitation techniques. Various methods have been proposed to predict mouse movement. We focus on target-agnostic endpoint prediction, which only takes mouse movement data as input and outputs the endpoint position. There are mainly two types of methods. One is regression-based method, for example, the kinematic endpoint prediction. Another type is based on template matching, for example, the kinematic template matching. However, previous methods can output the reliability of prediction, so it's harder to decide when to apply the results. For example, when a system needs to prefetch for latency reduction and incorrect prefetching introduces overhead, that system can operate earlier only when the results are reliable. Before describing the overall pipeline of our LSTM-based methods, we first define some concepts. Mouse movement is defined as a set of mouse positions sampled with a constant frequency. Mouse endpoint is a two-dimensional point where mouse click happens. The input for the prediction algorithm is incomplete mouse movements, and the output is possible clicking area, represented by the upper and lower bound in both x and y directions. To obtain the reliability of prediction, it is necessary to make the model output an interval rather than a point. This is the architecture of our model. It is a recurrent neural network composed of LSTM units. The input is incomplete mouse movements. Although the output for training data is endpoints, the model can output the predicted areas. In neural machine learning methods, the output is consistent with the training data, and it is hard to collect mouse click data with uncertain intervals. In this regard, we propose a custom loss function that can still be used to update the model parameters according to the true click position, even if the model output is an interval. It is composed of three functions. One is span loss, to reduce the span of predicted area. One is miss loss, to prevent true endpoints laying out of the predicted area. The third one is order loss, which penalizes the model when the lower bound is greater than the upper bound. The joint loss function is the sum of these methods. We built a web application to show targets for users and record mouse movements. Participants were asked to click 500 objects. All these targets were randomly distributed within a circular ring, and the direction is back and forth. Each time the user clicks, the new target will appear. We get nearly 4,000 valid movements from 8 participants. Here is the distribution of target distance and task completion time. We then sampling and cutting mouse movements to get training data and to train the model based on the training data. We compared our methods with the KEP and KTM. We use the center of our prediction area to calculate the error. The results show that our method reduces the prediction errors. We also evaluated the hit rate of prediction area as well as the length and width. The hit rate stays above 84% during the whole process. When the percentage of time is 90, the hit rate is about 96%, and the span in x direction is 48 pixels, and the span in y direction is 72 pixels. In conclusion, we proposed a deep learning approach for predicting possible areas where user may click. Prediction errors is reduced compared with previous methods. Thanks for listening.